So I want to thank everybody for joining us today. In today's class, we're going to be reviewing a few sections on rough carpentry, and we're here with Derek Hall, who is our expert in rough carpentry, and we're going to look at some submittals, follow-up inspections, and just general information. So thanks for joining us today, Derek.
Absolutely, Austin. As Austin mentioned, we're going to be going over rough carpentry, Division 6, primarily rough framing. So wood framing, it is what we do. The bulk of Harkin's work is wood frame multifamily, but even the remaining small fraction of jobs that are cast in place, metal stud, or other building methods generally have some sort of wood frame throughout the process. We should all know and understand this trade. It's literally what we do.
And at some point in your career, whether you haven't already, you will come across wood framing if you work at Harkins.
That's very correct, Austin. What we will go over during this session. What is wood framing? What are the components? How to review product data submittals? What and where are the important items and information you will need to review those submittals? How to review wood frame shop drawings, engineered trusses, roof trusses, prefabricated wall panels, prefabricated wood stairs. Creating and utilizing initial and follow-up inspections. All of these parts and pieces go together.
So Derek, at the end of today, what would the goal be for someone to take out of this class?
I would like anybody who watches this and really focuses in to be able to feel comfortable reviewing a submittal and going out into the field and utilizing that information that they reviewed in the submittal and pushed into an inspection to feel comfortable in doing that process the Harkins way. And we'll go through all of that step by step. The one thing that I'm not going to get into the weeds with is the step-by-step instructions for how to create submittals or create inspections. There are so many other resources on the Harkins Hub that you can access for that. I would like to focus on the information as it pertains to rough carpentry and wood framing.
Gotcha. And you don't expect anybody to be an expert after this class? Because, how many years of framing do you have under your belt?
20 plus years of framing. And no, you have to do something for 10 years straight or 10,000 hours straight to be considered an expert. I want you to feel comfortable reviewing a submittal and doing some base inspections to ensure that what Harkins has purchased and what our architects and engineers expect us to build is what is in place.
Awesome.
So Division 6, rough carpentry, wood framing. What is it? Rough carpentry or wood framing is the skeleton of most of our buildings, creating both the structural and non-structural base for partitions, floors, and roofs. So basically, guys, it's the internal system that holds it all together. It is the very beginning of the process after concrete goes in most projects that we're doing with Harkins today.
And probably one of the most reasons it's one of the most important things we do, because if it's our structure, and you mess something up there, it could be bad.
It affects everything.
Yeah.
It's just like trying to frame a building on a foundation that was put in incorrectly. It's not going to work. If you put this material in, if you build the walls in properly, something is not going to work, whether it's electrical, HVAC, your roof systems, your siding, your stonework. If you don't do it the right way, it's going to cause problems down the line. So what are the components / terminology? Structural, non-structural. Structural is a component that is taking weight from above generally. It is supporting the structure above. Exterior walls are 9.9 times out of 10 structural walls. They're carrying your floor load, your roof load, all the way up. Beams are considered structural. Posts can be considered structural. Non-structural are generally your interior partitions. Just because it's interior does not mean it's non-structural, but the filler walls that create the rooms a lot of times are non-structural. And most plans are very clear on what is structural and what is not. Stud spacing that you're going to see generally is going to be 1 foot, 16 inches, 19.2, commonly referred to as diamond framing, or 24-inch on center. 24-inch on center you will only see on non-structural walls. 19.2 you generally see in floor framing. 16 and 1 foot you generally see in structural components. Now, if you're seeing a 16 on center nomenclature in your plans and you see the DBL mark after it, that'll mean that you have a double stud at 16 on center. And that will continue through for 1 foot on center, 19.2. It can be consistent throughout. Pressure treated material is generally green. It can come out as a more yellowish color, but it has been impregnated under pressure with a material that will keep it from rotting in wet conditions, or in conditions such as in contact with concrete or the ground itself. FRT treated or fire rated material. This can be posts, plywood, lumber, anything made of wood can be FRT treated, and it is very specifically called out in your plans for use. It's very important that when this material is called out that it is utilized. It will affect your overall building design and sprinkler makeup. So this is one that you have to pay a lot of attention to.
Yeah, that's a note that you don't want to miss.
No,
if you miss that note, you're in big trouble. So you want to keep your eye out for FRT for sure.
Absolutely.
And are there different building types that you most will always see FRT, Derek, or is it?
Yes.
Can it vary?
So it can vary, but as you move into NFPA 13, you're going to see it a lot in roof systems, floor systems, wall systems. NFPA 13R, you may see it a little bit less, but it is utilized. Anything out past 13 and 13R, you're going to see it constantly. And it is, as Austin mentioned, it is so important that you pay attention to this when you find it in your specs and plans. So we'll move on to Southern Yellow Pine. This is another really important item to pay close attention to. Southern Yellow Pine, otherwise known as SYP, is generally used on bearing walls that will receive more load than a normal wall throughout the building, a normal load-bearing wall. And they'll designate that as a Southern Yellow Pine. It has a tighter grain structure and is rated for higher capacities. Your normal framing lumber will be SPF. And it may not say SPF on it. It may say SP or SF, but it is spruce, pine, or fir. It is your standard 2x4.
Are those hard to get mixed up, or will they, like you said, SP, and there's an SP in the other one? Is that something to?
It is something you have to pay really close attention to when in the field. I've seen plenty of occasions where Southern Yellow Pine designated wall will have SPF material in it. The sooner that material hits the site, or the earlier the material hits the site and you're able to see it fresh off the truck, it has a visible difference. The Southern Yellow Pine is a whiter, more yellow color than a tanner SPF. The Southern Yellow Pine is also much better designated. The stamps on them are much clearer. A lot of times they'll have crown indicators on them, such as arrows showing which way the material crowns. Whereas SPF, which is your standard wood 2x4, 2x6, 2x8, generally does not, and they are not marked as clearly. When in doubt, question it. That's my best recommendation. If you're unsure that a stud or a sole plate or top plate is Southern Yellow Pine when it's supposed to be, get your carpenter involved and make sure that it is. Headers, beams, LVL, glue lambs, and PSLs. We won't get too deep in the wood or into the weeds with this, but headers are generally a buildup of larger 2x6s to 2x12s, sometimes encasing plywood, sometimes encasing insulation for exterior walls that transfer load over an opening. such as your window openings, door openings, and so on. Sometimes the headers will be in the wall, sometimes they'll be at the floor system, but they're fairly standard, and if it's referred to as a header, 9 times out of 10 it will be SPF and made out of multiple lambs or layers of 2x material. They can also be made out of LVLs as well. LVLs are a laminated beam, very similar to plywood, but impregnated with much more glue. They're almost always a bright yellow color. Beams is a blanket term for headers, LVL, glue lambs, and PSLs. They transfer load generally over larger areas. So if you've got a non-congruent load from above where the structure below does not match the above structure and you need to transfer load from one area of a building to another, you're 9 times out of 10 going to use either a drop beam or a flush beam. Drop beams are below the joist. Flush beams are exactly as it sounds, flush with the joist and connected with metal connectors. Glue lambs, they'll stick out like a sore thumb. They are multiple 2x materials, almost specifically southern yellow pine or pressure treated, that have been glued together under pressure. And we're seeing less and less of those as the years go on. A PSL is almost the exact same thing as an LVL, except it's in post form. And you'll see PSLs called out in a lot of corners of buildings, areas that receive a lot of roof load, or large openings on either side of large openings, transferring load from above.
So Derek, something that I've seen a lot on projects recently is it's calling out for a PSL, but the framer tries to just throw in a stud pack.
Absolutely.
Now, what can you just kind of talk on that and why it's important to actually do what we're supposed to there versus?
So the difference between a PSL and a stud pack, which is something framers will do if they can get away with it because it saves them a lot of money. PSLs are much more expensive than 2x4s, and that's for a reason. PSLs have the capacity to carry much more load in a smaller format. So if your carpenter is utilizing 2x4s for a PSL, say it's a 4x4 PSL, nominally 3.5 by 3.5. Your carpenter puts in 3 2x4s, giving you 4.5. May seem like it's equal, should be fine. It's not. Those studs are not rated for the same capacity as that PSL. Where they're using 3 studs, it's possible that they may have to use 8 studs, impacting your electrical locations for outlets, impacting where you can put hose bibs out the side of your building. There's a lot of ramifications to not following the plan. Furthermore, if you have an astute inspector who sees, and the inspectors are looking for this now, that it's supposed to be a PSL, regardless of how many 2x4s you put in that location, it's not going to pass.
Mm-hmm. And a lot of times they're put in weird locations, like in tub chases or in places that are hard to get. So if you have to go rip those out at the end of the day, it can just be a nightmare and put in the right thing.
Absolutely. And if you're talking an exterior wall, it might have 60 ring shank nails from top to bottom holding that thing in, and you're going to spend the better part of a day trying to strip this out, building temporary walls if it's under heavy load. It's something that you really have to pay attention to in your framing process. Jacks, kings, cripples, sole plates, and top plates. This is just basic terminology generally around openings. A jack stud is the stud, PSL, or post carrying the actual beam or header. So it is the actual component that is directly underneath the header beam system that is transferring the load to the floor below. A king stud is a 2x4, 2x6, whatever your stud composure is. I mean, they can even be up to 2x10s at times. That goes up alongside of the header and the beam and the jack, header, beam, or jack. So where you have your jack underneath, your king runs up beside, and that further strengthens the beam in the horizontal position. This is something that we'll go over during the review part of this presentation, but it is very important that you check your schedules and your plans, because it will tell you how many jacks and how many kings based on opening sizes. Where you have a 3-foot opening, your engineer may require 2 jacks and 1 king. When you have an 8-foot opening, it may be 5 jacks and 2 kings. And once again, if you've got an astute inspector and he's going around checking these items, if you don't have those in place, you could fail your inspection. Furthermore, your framing inspections after your MEPs have gone through, if you've got wire running through those, you now have to remove all your wiring, plumbing, anything else that was there. Put your new king and jack system in, and then put it all back. So moving on to cripples. Cripples are generally the small 2-bys that make up the difference in the height of an opening. For instance, above a header or below a windowsill. Those are cripples. It's just terminology. So when you're out in the field and somebody says, that cripple looks bowed, they're not being offensive. It's framing terminology. Sole plates and top plates. Your sole plate will always be the bottom plate on your wall. That can either be SPF, Southern Yellow Pine, or pressure treated. If you're going on top of a concrete slab or concrete wall, it will always be pressure treated. In the heavier load-bearing walls, you may see Southern Yellow Pine, Southern Yellow Pine pressure treated. Most pressure treated is Southern Yellow Pine, but everything will be designated out in your schedules and your plans. Top plates is exactly what it sounds like. The plates on top of your walls that make up the horizontal of your wall system and holds all your studs together. The thing to pay attention to with top plates is if it's single top plate, it is indefinite or most definitely a non-load bearing wall. You won't see that too often. We generally require double top plates on everything, but it's something to question if you do see. If it is a load bearing wall, it will always have double top plates. That being said, you also have to check your wall schedules because the second plate may not always be a 2. If you're building a 2x4 wall, your top plate, the second of the 2 top plate may be a 2x8 to span a demising wall for fire blocking. This is something that gets missed all the time, and it's something you have to make sure when you're doing your initial inspections. You check your wall schedule, and wall 5F may be a 2x4 top plate with a second top plate that is 2x10 that covers the adjacent wall as well and makes up your fire blocking for that wall system.
That's a great point there.
So sheathing is a blanket term for plywood OSB used on floors, walls, and roofs. Very important you pay attention to the schedules in your plans, whether you're using zip wall, zip roofing, standard OSB, actual plywood, FRT rated plywood, and that can be used on walls and roofs and floors. It's one of those things that you need to pay attention to early in the project and make sure that your carpenter has the right material on site and he's using it in the right locations.
Well, and a lot of times FRT plywood and non-rated plywood can also get intermingled. Depending on where your rated walls are below, you may have to have FRT plywood. Like on an exterior wall, the outside edge of your building might be FRT versus the inside.
And it has to do with proximity to other buildings and structures. That there's a lot to pay attention to, and you get one shot at it. And that's when it's going up the first time. And if you can focus in on those, give yourself some notes to follow, there's no doubt in my mind you can get it right the first time. So tie-down systems. This is an ever-expanding process that we see here at Harkins. Tie-down systems have been exploding since the early 2000s and are a part of every building at this point. These are generally made by Simpson or United, and they are devices that do exactly what they say they do. They tie the building down to the foundation. There are many different makes or models of tie-down systems, ranging from boots that connect to all thread that runs all the way up to the top plates, to intermittent tie-downs that go between floors. There's a lot of parts and pieces to this. And it's very important that you check your specs and figure out where all these items go prior to their installation so that you know what you're looking for. One thing I didn't mention in the slide is shear walls. Shear walls are another item that we're seeing more and more of today in wood framing. They they do not vary from a normal wall very much. The stud spacing may be slightly different, and the plywood makeup may be slightly different, but the nail pattern is most definitely different. It is a wall that is placed either on the corner of a building or within a building that is always sheathed with either drywall or plywood and has a very specific fastening pattern that must be adhered to. Shear walls are made for wind resistance for the building and earthquake tolerance. And you will always have a shear wall plan to go off of in your contract set.